Hi, purpose of today's video is to reveal a new technique for solving equations that's different from what we've used in the past in Algebra 1 and early Algebra 2. Turns out that all we've ever been using to solve any equation is inverses. So just a quick review, we want to get at the value of x, and all these things, the 2, the square, and the 1 have been added to it, and that gave us the result of 5. To find out what x had to be to get that result, we were going to undo the 1, the square, and the 2. All of that by using what we call inverses. So the inverse of add 1 is subtract 1, so I subtract 1 from both sides. The inverse of square, because I'm going to get rid of that, is square root, so I square root both sides. Don't forget absolute value, and then the inverse of absolute value is positive or negative. And then right down in here, we're going to inverse add 2 in both cases to get my final solutions. So that's how we solve using inverses. Basically, we just keep undoing things one step at a time until we get back to the x where we started. This is no different. Get rid of that one. This is no different than if we have an absolute value equation. We're going to invert the 1, so we have now absolute value of x plus 2 equals 4, because we subtract 1 from both sides. And then we're going to invert absolute value, which is a plus or minus situation, just like I did in the previous example. And then we inverse the add 2 in both situations to get the two solutions. Even if we studied linear equations, this is an example of a linear equation in point-slope form, kind of, but here's the slope of x plus 2, and then we add 1. We can solve this a variety of ways, but consistent with the earlier approach, I take the inverse of add 1, and now I see that there is 2/3 times x plus 2. If I want the 2/3 to go away, I'm going to invert multiply 2/3, which you could say is divide by 2/3 or multiply by the reciprocal 3/2. I like multiplying. So I multiply both sides by 3/2, that's the inverse of the 2/3, and then we invert the plus 2, and we get the final solution. So again, this is just 3 different ways to show you that inverse is king. Inverse is the way that we solve a variety of different kinds of equations. Suddenly we get to this quadratic. In an earlier video, I explained how if we try to use the inverse approach, it's going to fall flat because we don't know how to separate the x squared from the x. However, we have spent the last couple weeks working on factoring. Now that we know how to factor, we're going to take this quadratic expression and factor it. The important thing to recognize here is that we cannot use inverses at this stage because I don't know how to invert 2x minus 1 from the 2x plus 5. Instead, we're going to use the zero product rule, which is a logical argument. It goes like this. If this number times this number, again, the whole thing is a number, and this whole thing is a number, if they're multiplied together and I get 0 as a result, then I must be able to conclude that either the first one or the second one has to be 0 in order to make this a true equation. So if the first one was 0, 2x minus 1 was equal to 0, then that would lead x, by applying inverses again, that would lead x to be 1/2. And in the second situation, if I apply inverses, I'm going to get x to be negative 2.5. So the point is, before we start using inverses like we always have, we have to use a different strategy, which is called the zero product rule. I keep mentioning this zero product rule, and I will keep mentioning a zero product rule because the zero product rule is the new concept. And it's what many students fail to recognize. The most important part of the zero product rule is the zero part. This is going to guide how we solve quadratic equations, and I'm going to show you what I mean in a little bit. I would like to point out that in some special cases, we can use inverses or factoring to solve certain kinds of quadratic equations. This one is a difference of squares, so I could use the factoring format, in which case I get factors, and I use the zero product rule to solve, and then I'll apply inverses. On the flip side, I could just set one perfect square equal to another perfect square and just use inverses with no zero product rule. Here's how that's going to look. We have the 3x plus 5 equals 0 or the 3x minus 5 equals 0. That's the zero product rule. Inverses tell me that 3x equals negative 5 or x equals negative 5/3, or 3x equals 5, x equals 5/3. So those are our two solutions. The inverse approach, just add 25 to both sides, and then we're going to divide both sides by 9, take the square root of both sides, and that's where we get the absolute value, and that to get rid of, we're going to get the plus or minus, which we've done before. I hope you guys are still pretty good at that. And as you can see, we end up with the same two solutions no matter which approach we take. The point of showing you this is the inverse approach is an entirely different logical approach than the zero product rule approach. And in many, if not most, quadratic equations, the zero product rule is going to be, at least in high school math, the zero product rule is going to be the more frequently used than the inverse rule, at least in high school math, like I said. So here's why I keep mentioning zero product rule over and over and over again. Here are two equations, and both of them can be considered quadratic because there's an x squared and an x term in each. But this is not a quadratic expression on the right, this is a linear. Same thing here on the right-hand side, this is a linear expression. But the equations are yet quadratic. In order to solve quadratic equations, then, I'm going to have to do a little bit of cosmetics. I'm going to take the 16x and the 12 and subtract them from the right-hand side to send them over so that I have a quadratic expression equal to 0. The equal to 0 is the must-have. You gotta have the equal 0 in order to use the zero product rule. The rest of this is reminding you of the factoring algorithm. We bust up the middle term according to the Xbox. We factor by grouping the first two and last two, and we end up with two factors equal to 0. Once again, this is the next step, zero product rule. I'm going to ask you guys to write either ZPR or zero product rule every time you use it as a type of rosary. Every time you use it, say, this is a new trick, I'm using the zero product rule. If two numbers equal 0 when they multiply, then either of them has to be 0 in order to make it true. That's the zero product rule. So in other words, if you have to solve an equation like this for homework, your first step is to go quadratic equals 0, then factor, oops, got ahead of myself, quadratic equal to 0, then factor, and then use the zero product rule. Checking your answers, of course. Even if they're negative fractions, you can still check your answers. So let's look at this example. Same deal. I have to make this quadratic equal to 0. That's my must-have in order to use the zero product rule. Now the other thing here is this is actually easy factoring. It's a two-termer. They only have one common factor, that's x. So it factors real nice. And now I see a product, two numbers, that multiply to give me 0. So there again, I state zero product rule is the key, and then get each factor separately equal to 0 and solve. So, quick summary. If you're asked to solve a quadratic equation, first job is to go quadratic equals 0. You have to rearrange the equation so you can get it into factorable form. Then factor, and once you have factors, two factors, equal to 0, then use the zero product rule to break up and find the values of x that make the equation true. That's the process, zero product rule. Hope that makes sense. Email me with questions if you got them. Thanks.